Just as in section 8.1, because we have proven that the sampling distribution of sample proportions is normal, right? And we prove that with a slightly more complicated n times p times q is greater than or equal to 10 in this section. Because we have that, then we can find probabilities or p-hats depending on what the problem calls for. All right, so I'm going to show everything in the next 2 pages with StatCrunch. But of course, if you're using a TID4, then I'll show that at the very end. All right, so let's keep that sheet in mind. We'll use that, and as per usual, you don't have to memorize it because it's in your exam notes packet. So it's just a question of knowing how to use it. All right, so we have a random independent sample of size n equals 876. It's taken from a population where the probability of success, p, is 0.12. Find the following. Include shaded and labeled graphs, give 4 decimal places for probabilities, blah, blah, blah. All right. So we're going to describe the sampling distribution, including working symbols. Now, just on a side note, you'll notice that random and independent were given, right? So they're already set. Now, the problem didn't ask for this, but I'm just going to kind of throw this in there. Do we have normal, right? Because we're going to add, it's going to come right here, right? We're going to want to say, hey, the shape is normal. So do we in fact have that? Well, we'll have it if NPQ is greater than 10. Well, N is 876. It says it right here. P, and mathematicians, by the way, we just don't write the dots in there, but they're there. What we mean is multiplying. When we put 3 letters together like that, we mean to multiply them. So I'm going to multiply it by 0.12. And some people don't like the look of that, so they'll put parentheses around it, but the parentheses are just standing for multiplication. And then Q is the probability of failure, right? So if P is the probability of success, Q is the probability of failure, and they're complements of each other. So it's 0.88. So I just need to find that number. And again, the problem didn't specifically ask for this, so you wouldn't really do this unless it was asked for, but I'm going to do it. All right, so I'm going to go over here to Desmos. I'm going to do a couple of things. First thing, I want to prove to you that I was right. So this is 1 minus 0.12. Look, in fact, it is 0.88. 876 times 0.12 times 0.88, oops, 88, is 92.506. And just to show you, it actually doesn't matter if you use parentheses or you use the multiplication symbol. It's all the same thing. All right, so this is 92.5, which is in fact bigger than 10. Yay! All right, and random and independent were both given. So given, done. So now I do in fact know that it's normal. Hooray. So now the center. Well, looking back at the central limit theorem, right, I've got the shape is normal. The center is the mean of the p-hats. So the mean of the p-hats, which was p, which is given as 0.12. All right. Then the spread is the standard error of the p-hats, or if you like, sigma p-hat. Either way of writing it is perfectly fine. This is kind of a newer way to write it. This is kind of the older way to write it. And it's a big square root. All right, so it's a big square root PQ divided by N. All right, well, P we know is 0.12. And you can put a little times dot in there, or if you like, you can put parentheses in there. Either way. Q is the complement of 0.12, which is 0.88. And it's divided by N, which was 876. Now I want to show how to do this carefully in Desmos, because people will mess this problem up. So let me show it in Desmos. I'll put it up here at the top. Okay, so when you take a square root, you want to actually remember to do the square root first. So then you want to do 0.12 times 0.88 divide by 876. Now I know what you're thinking. You're thinking, Alana, that doesn't look like what it looked like on the page. Actually, it's okay. So if you want it to look like it does on the page, when you hit the square root, after you hit the square root, hit a fraction button, hit division. Right? So what I did was I hit the division button and it created this fraction for me. And now I can type it like it looks on the page. But you'll notice it's the same answer, right? It's because I have to have the 0.12 and the 0.88 multiplied, and I have to have a division by 876. And both of those fit the bill. Oh, and for the record, if I wanted to do this with parentheses, I could do that too. So I could say, hey, parentheses, 0.12 times 0.88, close parentheses, divide by 876. And there you have it. The one mistake you don't want to make, and I'm loath to show it to you, but students do this sometimes. If you're going to make a mistake, what you're going to do is accidentally hit your arrow. And if you do that, you can see that the cursor is outside of the square root now. So if I hit division now, it is wrong, right? That's the wrong answer. See, the square root is supposed to be over the whole thing, not just the numerator, but the whole thing. So that's wrong. It's these values. These are the correct ways to type that. So let's make a note. Well, first of all, I forgot. I've already forgotten what number it was. 0.010979. And these ones, we want to keep a lot of decimal places. We're actually going to keep 5 or 6 decimal places on this. So we actually have to keep a couple notes. So 0.010979. Okay, so 2 warnings. Note number 1. Enter carefully into your calculator, which I'm assuming is Desmos. Although the TI-84, you'd be careful as well. That square root has to go all the way down here, right? It has to be for the whole thing. So that's a note. The second note is keep a lot of decimal places. Usually at least 5 or 6. If I want more than 5 or 6, I'll tell you. Or if I want 6, I'll tell you. But you have to keep a lot of them in order to keep your accuracy up for later on. Speaking of which, let's look at the later on. So they want us to be able to find p hat greater than 0.135. All right, so let's look at the table. Find p parentheses. That means we're looking for a probability. So we're going to put our mu, which was 0.12, that's our mu. Oh, I guess that's a third note. And our standard error, which is our sigma, in for the mean and the standard deviation. So we have one note, we have another note. So this is note number 1, this is note number 2, and I'm actually going to make a note number 3. I'll put it over here. Probably the most important of the notes. Well, they're all important, every last one of these. Right, we use these values in stat calculators normal. Right, in your normal calculator. In a TI-84 it would be in the normal CDF calculator, but right, you have to use these two values. These values meaning the center and the spread. And I wrote it in the table, right? The mu is the mu, and the standard deviation is the standard error of the p hat. Standard error p hat, that's what I'm talking about. All right, so if I want to find that probability, I'm going to put those values in and put p hat in. Simple as that. All right, so let's do that. Let me make this smaller, and I'm going to bring up StatCrunch and have it so that we can kind of see them side by side. Let me zoom out a little bit here, just so we can kind of see a little bit more. Okay, so in the mean position, we're going to enter the old mu, which was 0.12, right? That's p, that's our mu. And we're going to enter the standard error of the p hat, which is 0.010979. That's the one in particular you need a lot of decimal places for. And then I want it to be a greater than or equal to, and I want 0.135. Enter. And there we have it. So let me write that down. So the probability that p hat is greater than 0.135 equals 0.0859. It doesn't have any units. It's a probability. Probability doesn't have units. I'm also going to shade over here. So, right, this was our value, 0.135. That was the given value, and we were looking for this area. And we found it. Now, you'll notice, by the way, that StatCrunch always says X, because it doesn't know the difference. It also says, standard deviation and mean every time, right? So you just have to know this is a p hat in this problem, not an X. All right, now, only 10% of samples such as these have proportions smaller than. Okay, so smaller means we're going to be doing a left tail. So I'm going to switch over to a less than. We ran into this in section 8.1, but I'll make a little note. Smaller is a less than. And then I'll make a note right here. If it was larger, that would be a greater than or equal to. Just a little side note. Okay, so I'm going to switch to a less than right here. I'm going to keep my mean and my standard deviation. They have not changed. I'm still in the same problem. But the 10%. So only 10% of values are below this proportion. I'm trying to find the proportion. I'm trying to find p hat. And I know a percent. A percent that was given to me was 0.10. So I'm looking at this. So the 10% is my area in my left tail. So I'm going to get rid of this area right here. I'm going to type 0.10. And there we have it. So right here, that area was the known part. It was 0.10, and I was looking for p hat, right? The bar where this comes down. And I find that the probability that, and again, it thinks it's x, but we have to say p hat, is less than or equal to 0.1059, 106. I want 3 decimal places. Up here, it said 3 decimal places for p hat. So 0.106 is equal to 0.10. That's the answer I was looking for right there. Or if you like, you could write it this way. All right, I'm going to show how to do those two things with the TI-84. If you're not using a TI-84, you can skip ahead to the next video. All right, on the TI-84, we want to use a normal CDF for this one because this is finding a probability. So we'll use second normal CDF. We would say 0.135, and then we would say to forever, so 1E99. Then we have to put in 0.12, which was our mean, and 0.010979, and paste that in, and there we have the same answer. Down here for letter C, that's an inverse norm problem, right? Because it's this one, the second one. So we're going to have to use inverse norm, so second distribution, number 3, inverse norm. This is 0.10, and then I've just got to put these values in, 0.12, oh, 109, I keep messing that up. Oh, I did press the down arrow, but it didn't take. 0.010979. And this is a left one, so I don't actually have to show the old calculator because the old calculator is the same as this. You would put those values in and you get that. So this is a time when the old and the new calculator work the exact same way as each other. If you want to write those down for yourself, you can. So for the TI-84, it's normal CDF. you go 0.135, 1E99, 0.12, 0.010979. There we go. Down here on the TI calculator, it would be inverse norm, 0.10, 0.12, 0.010979. If you have a new calculator, then you would have to add the word left to that. Old calculators don't have that option, so they only do left tailed, so that's all they have.